welcome to Jinghua Education. I'm Steven. In this video, we're going to talk about Math 12, Trigonometry Part 14, which is how to graph secant and cosecant functions. Okay, if you haven't done my Part 3, Trigonometry Identity Hexagon, please go back to check it out. It is very important to this one. Okay, we total have 6 trigonometry functions, and then these two will be the last two. A lot of students is pretty scared about these things because they haven't seen them a lot. Not like a sine and cosine. This is like a very not familiar. Actually, these two is pretty nice one. They are not hard at all. Okay, as long as you know how to draw sine and cosine functions, these two will be exactly same. Not exactly same. It's very similar. Okay, we just do extra steps here. What extra step? The step we learned from transformations. How to find the reciprocal functions. Okay, let's do a quick review how to find the reciprocal functions on the normal way. Alright, we have a function, for example, like that. On reciprocal functions, we need to make sure we have asymptotes, vertical asymptotes at x-intercept of original one, right? And then we're making them invariant point, and then we make across them. And that's it. This is how to finding regular reciprocal functions. Okay? Okay. In this case, here, cosecant functions is the reciprocal function of sine function. Secant function is the reciprocal function of cosine functions. As long as we getting these two part, and then we're done. We just do draw a normal sine functions if we're looking for cosecant functions. Draw a cosine function if we're looking for a secant function. And that's it. Let me show you in the graph, showing in the actually example here. Okay, so we're trying to graph y equal to secant 1/3 theta. Okay, so we don't know how to graph this yet, but we do know secant 1/3 theta equal to 1 over cosine 1/3 theta. We learned how to graph that one, right? So 1/3 theta, this is our b. The b equal to 1/3. So the period equal to 2 pi over 1/3, which is equal to 6 pi. Okay, from 0 to 6 pi, that is our one period. From negative pi, 6 pi to 0 will be at the other period. So we have a 2 period in our x-axis. Let's going to draw the cosine functions. Cosine function is a shape. So start from the top and then going down to the peak, out to the valley point, going up and to the peak. And the other side is same, from the one part going down to the bottoms, going up and to the top here. Okay, so this is our cosine function in 2 period. Now let's go to draw the secant functions. Secant function is a reciprocal function of cosine functions. So in order to draw the reciprocal function, we need to finding the vertical asymptotes. So vertical asymptote will be the x-intercept of original functions. We got 1, 2, 3, and then 4. Here. We got 1, 2, 3, 4, 5 areas. Let's just draw these things here. Okay, we have asymptotes. Now we're looking for invariant point. Invariant point is going to be -1. So we know cosine function, the bottom part is -1. So it's the peak is here. So the secant function is going to be a U shape, and then with opposite of this curve here. So whatever is U shape, opposite to the cosine curve. Okay, we got invariant point here. So we got U shape opposite of cosine function. Invariant point, U shape opposite of invariant point. There we go. Now the right curve is our secant functions. So far so good, huh? All right, let's see the next one. Okay, we have cosecant 2 theta. We don't know how to draw cosecant yet, but we know how to draw sine 2 theta. The sine 2 theta equal to what? Sine 2 theta equal to, let me close that. Okay, the sine 2 theta equal to b equal to 2. So the period equal to 2 pi over 2, which is equal to 1 pi. So 0 to 1 pi is one period, negative pi to 0 is another period, in the middle point is in here, and then we just go in a duck, right? Duck is sine function. A duck is sine function here. Here we go. So now we have a two period of sine functions. Now let's go to draw the vertical asymptotes. 1, 2, 3, 4, and 5. There we go. And then invariant point -1, just draw U shape against sine functions. Invariant point +1, U shape against sine functions. U shape here and U shape here. The reason is U shape is they cannot touch the vertical asymptotes. So this all the red curve is our secant functions. Okay. Again, sorry about the graphing. It's pretty hard to draw the tab. Okay. If you have any questions, please comment below. I will answer your question in my next video. Thank you for watching.